All right, thank you everyone for joining. We're going to kick off the webinar now. The topic for today is Kubernetes connectivity and enterprise considerations and how to choose the best option. We have Cody McCain as our host today, and I'll hand it off to him.
Thanks, Andy, and welcome to all who have joined today. I'm looking forward to taking you through kind of a little bit of a history lesson in where we've been with traditional networking and what the new landscape looks like. And we'll spend quite a bit of time today diving into both technical scenarios, but also the people and processes that are necessary to work in this new cloud native world when it comes to securing platforms like Kubernetes. So let's get started. And also, before I begin, please note that during this webinar, let me see if I can get that to advance, we will have a Q&A panel at the end. So please feel free to submit any questions to the host using the chat feature, and I will try to address as many questions as I can at the end. Typically, we take about 30 minutes to dive into this topic. This event will be recorded and sent to the registrants. And so we love to hear your feedback and look forward to chatting with you about your cloud native security needs. So let's get started. So let's take a look at application development with enterprises. We all at this point in time know about microservices and we know about containers. Many of us have already used dynamic orchestration, and many of us have moved workloads into some sort of public cloud. In some cases, we may have actually built our own cloud on premise. And those new technology primitives are enabling us to move faster, start and stop, and be able to test new scenarios without having to worry about the capital investment or the time to market that it takes to get a new feature or a new product out when it comes to technology. With things like microservices and containers and being able to dynamically orchestrate them, what we're seeing is it's about 900 times faster to start up a container than it would be in the past to provision, a virtual machine or to provision actually physical hardware in the data center. So what this means for your business is that we're seeing, on the order of 10 times more workloads being spun up and down daily within large data centers. It also means that these workloads aren't staying around very long. The typical lifespan of a container could go from minutes for handling something like a spike in traffic. If I'm an online retail store and I'm on Black Friday, I may be scaling up my number of instances to handle that traffic. And then when that traffic has subsided, those containers go away. Whereas VMs and physical machines typically had lifetimes of calendar days or months or years. And so there's a lot of turnover that's happening within the data center in terms of what the workload topology looks like. And this is creating a massive new demand on application networking and security. The first thing is when you have things that are turning over all the time, and all of these are first-class network talkers, meaning that they've got IP addresses, they're talking on the network, you're seeing a lot more network changes happening. The other thing that happens is that not only are we seeing a lot of changes on the network, there are a lot more things that are connected to the network. And so what this means for an attacker is now I've got a lot more targets that I can try to penetrate your organization with. And so all of these things, coupled together are presenting a lot of challenges within the enterprise. One of the things that is not a new problem is this tug of war between risk and agility. We want to move fast. We want to launch products and IT and implement IT technology that really differentiates us as a business. But we also want to do that in a responsible way. There's been a large spike in the number of data breaches over the last several years. Many of them have become very noteworthy and reported on within the news. And so there's a lot of apprehension for how fast we run. We have to consider what the people and processes and the cost of these data breaches are. and how we're going to adapt those for this new agile world. We also have to think about increased compliance. With the announcement of GDPR and the new compliance coming out of Europe, we have to be concerned about what is the requirements on us as an organization to actually meet those new requirements. And the unfortunate thing is with the move to public cloud and even with the move to private clouds, our understanding of automation is still in its infancy. Things like Kubernetes have definitely changed that picture, but we're still learning how to automate our processes. And unfortunately, the development community has automated the process of launching applications much faster than our security communities are in being able to modify rules that protect those launches, right? So we need to move the automation and make it pervasive throughout the organization, not just in the development and the systems management side. We also have a lot more threats that we're dealing with. As I mentioned, the increase in the number of threats. There's a lot of threats that we really don't know about. Even at the beginning of this year, we found out that our microprocessors and the way that they compile code was extremely vulnerable. We found out that our developers are beginning to use more and more open source software, and the availability of apps for downloading, installing, and integrating them into larger systems is a lot more prevalent. That's great, meaning that we can build systems faster and we don't have to reinvent the wheel all the time, but it also has the downside of we don't always know what's being installed in our organizations. We also know about spear phishing and other attacks where not only is it important now for data to be encrypted at rest, but we also need to make sure that we're protecting our data as it's moving across the network. More and more applications are delivering personally identifying information all the way out to mobile devices and other endpoints that were not available in the past. And then finally, we want to make sure that as an organization, when we're deciding where to put our compute, we don't want to get locked into something. We don't want to get locked into a specific cloud or to a specific on-premise technology. We want this ability to go to the most cost-effective solution. We also want to make sure that we understand containers and these microservices and what their security boundaries are. There's still a misconception within the community on how to go about securing a container. A lot of the principles that were used in the past for virtual machines and such no longer apply in the same way. We also want to make sure that we can support global operations. And this means that we don't want to have to, as we expand globally, reinvent all the policies. We want to be able to federate these concepts to wherever we're moving across the globe so we have a unified view of the security domain. So I want to take you back in history and start taking a look at how did we get here. Let's take a traditional view of network security. Most everyone is familiar with what I would call the three-tier model. And in this model, we would have inbound traffic from the internet, and it would hit some type of a front end. Our service would get, our request would get serviced in some sort of a back end business process, and it may pull and exchange data with some type of a data store. In this type of a model, most of the traffic that we actually saw was north-south traffic, meaning that there wasn't a lot of intercommunication between processes within the data center. Most of our communication was with our customer and being able to take requests and deliver results back to the customer. But now in the age of social networks, machine learning, and all of the other types of things that we have, we're going to find out later on that that is actually beginning to change. Another thing that we thought about in the traditional networking model is that we would create a perimeter around our processes in the data center. And we would basically put a firewall in place that would protect us from the untrusted world of the internet. And we would assume that everything that's sitting behind our firewall is trusted. That allowed us to create very specific rules that said things like, I want to allow traffic into my application from the internet, and I'm only going to allow traffic on certain ports and to certain destinations. All of this was great from a firewall perspective, but the unfortunate thing is that everything was tied to IP addresses. Now that works fine in a traditional application where you're dealing with VMs and physical boxes. And again, these things don't change very often. So if I tie it to an IP address, that IP address really became my identity, and that was okay from a traditional standpoint. The other thing that was done is when I wanted to put that rule in, let's envision that I had a developer come along and said, I've got a new application that I want to launch. And I know that my new application is going to require several different rules. Maybe it's a new mobile app. And so now I need to start accepting traffic on a particular port for my new mobile app. Well, unfortunately, the developer in the traditional world can't just go log into the firewall and add the rule that he or she needs to enable their app to function. What it would look like more traditionally is, first, the rule would be proposed by the developer and handed off to some type of a security or compliance organization that's going to take a look at a spreadsheet of all their policies and determine how does that rule map into the policies. Is this a valid rule? Is it going to play nice with other policies that are there? After that occurs, the next thing that would happen is that we need to make sure that the network engineering team can take that rule, and it's not going to conflict with anything that's on the existing firewall. You know, unfortunately, the firewall is the source of truth in this case. And so when we're reconciling new rules, we have to consult a live source of truth. And that reconciliation is, and the only person that can do that is the network engineer. But before a change could be made, we need to now consult our change management committee, because we can't update this live firewall because there are other things within it that we might fat finger. So we need to wait for a change management window, right? And as soon as that change management window is approved, the networking engineer can come in and change it. But that's not the end of the story. The other thing that we have to consider is, depending on the type of shop that we are, you know, this may take, you know, days to week to actually walk through this process. We talk with customer after customer, and we find that the slowest or the weakest link in the chain of deploying applications is not how long it takes to develop the application, but how long it takes to put all of the policies and the other environment changes in place so that that application can function. Additionally, we have to worry about, well, what is the actual technology of that firewall? If I'm using Cisco or Palo Alto or Juniper, I have a network engineer that is using a very proprietary set of commands and knowledge about a very particular type of firewall. And typically, there's not a lot of crossover between a network engineer and a developer or the other pieces of the organization that need to interact with that. So I have siloed the policy implementation function within a particular group. And so no matter how fast I move from being able to create rules and identify the policies and making sure that they align correctly, I can only move as fast as the size of my network engineering team, because they're the only ones that have access to the policy implementation devices. Finally, now we have to worry about threats. And so as I mentioned earlier, in the traditional sense, we have a untrusted side and a trusted side from a perimeter perspective. And as threats move across into that trusted side, some of the things that we have to think about is, well, in the traditional model, we would just create another vertical separation. And that gives us a sense of security that we've got this, you know, DMZ zone where things are kind of pseudo trusted, but again, there are still holes that are poked back into our back end. And as we go further down the separation and expand out the number of services in our intranet, unfortunately, there's no granular policy that are actually protecting the backend services within that intranet. Once I've passed that last boundary and I've come into the intranet, now it's an open game on any service that's living here. And so what we're really wanting to do is increase the granularity of our security policies and be able to offer more targeted protection. So let's review what we've just discussed. In the traditional networking security, we have north-south traffic being what the predominant model. Typically, we have centralized firewalls. We're depending and relying on IP addresses to stand in for identity of applications. We have coarse policies in large zones. So if I'm within an intranet zone, the policies are not going to block me from talking to other things in that intranet zone. And rule changes are hard. We have manual compliance checks, manual reconciliation. A lot of times we were dealing with change windows, hoping that we have the right network expert available to make the change that we need. And these processes can take days to weeks. So what do we do in this new cloud native security, or this new cloud native world with security? The idea is that we're starting with this monolithic application and we want to break it apart into microservices. And what that really means is we're taking something that traditionally communicated in process, and now we're moving all the communication between those components over the network. Thus, what is leading to the overwhelming increase in the number of network talkers in a microservice world. Where we traditionally would deal with one IP address in a monolithic application, now every component is independently addressable on the network. And if you consider that each one of those individual components can be scaled to handle dynamic load, each one of the instances of those components as they're scaled also gets its own IP address. And so it's not uncommon to see orders of magnitude or 2 orders of magnitude greater number of processes running in a data center on the network in this sort of model. One other thing to point out from this picture is on the left side with the monolithic application, those IP addresses are long-lived. Those are typically assigned to VMs or bare machines, where the ones on the right side are more ephemeral. So these IP addresses are constantly changing based on the creation and the destruction of the individual instances of those microservice components. So to look at this a little differently, now we're dealing more with east and west traffic in the data center. As we look at things like social graphs and take Netflix as an example, or Facebook or Twitter, where it's important for back-end computations to be running to be analyzing relationships between the data. We see a situation now where the east-west traffic is the predominant mode over the northwest traffic, because all of the microservices in the data center are exchanging information with each other to analyze data. And so we get a picture that looks something like this. Now, if we were to apply our traditional logic and our traditional strategy for protection of the data center in this east-west mode, where we have a lot of distributed microservices, we would say, well, we can just put a perimeter around those and everything's going to be okay, because as long as you're within that perimeter, you're safe. Again, as I've already pointed out, we know that there's advanced persistent threats out there, and as soon as they enter that perimeter, if there's no other barrier for them to pass, now we end up with a situation where we have a quick infection occurring within the network. The next step then for us to consider, all right, let's control my mouse here, is what we really want to do is take that perimeter barrier and we want to shrink it down and put individual barriers around every single microservice within our organization. And that way, if we do get a threat into any one of these microservices, all of the other microservices are going to be protected. And the reality of the situation is that you're going to get a threat, right? There's only 2 organizations in the world: those that know they have been, those that know they've been penetrated, and those that don't know they've been penetrated. And so what our real goal here is to reduce any type of a blast radius from a penetration that occurs. But then that begs the question, okay, so we now have our containers and our microservices protected, but what if an attacker is able to penetrate our network and spoof IP addresses of the other containers? Again, at the end of the day, we're still using IP addresses for implementing rules. It just happens to be that they're being rendered dynamically based on the current state of the scheduler. And so we still need to be able to protect against this, especially for traffic that is unencrypted in transport, right? We want to prevent any eavesdroppers from sniffing in on private data as it moves back and forth between microservices. So the thing that we really ought to be doing is not only putting the firewalls around the containers, but also making sure that we dynamically encrypt every link of the communication that occurs on a microservice graph call. And you may be thinking to yourself, wow, how do I do this? How do I go about standing up TLS and other encryption mechanisms between every microservice? Well, the key is that you can't do this manually because the microservices are changing too often, just like you can't configure the firewalls manually. We've got to have some type of integration with the underlying scheduler and orchestrator that's orchestrating these microservices so that it can do that on our behalf using the metadata that's available within the system. So if I were to look at the topology between these two different mechanisms, in the traditional mode, and where we have centralized firewalls, we typically would take something like a VLAN and isolate different segments of our network. So maybe one VLAN would be handling the DMZ, and the other VLAN would be the intranet. The other VLAN would be our connection to the internet, right? So we have these very coarse ways of segmenting traffic. In the cloud native paradigm, now it becomes important for us to have that firewall on every single container because the mesh now is a more peer-to-peer topology. The other thing that's important for us to understand is if we rely too heavily on cloud native mechanisms for security, we have two problems. One, they may not be granular enough to address the container security. And two, we are now having a vendor lock-in with a particular vendor, and we may want to have the flexibility to migrate apps between different vendors or our on-premise sites whenever it makes sense from a cost perspective for us. And so we need to adapt a security mechanism that is homogeneous across all of those providers. Finally, when we come to the cloud native security process, it's going to be a little different than the traditional handoffs that would happen in the traditional process. In this process, on the cloud native side, we would take the compliance or the security team, and they would look at policies. And it's important to first, before I start applying policies to applications, create a nomenclature using labels that will describe what I'm protecting. Instead of policies being tied to specific applications, now policies are starting to be tied to specific behaviors or personalities. For example, if I've got an application that is an LDAP server and I've got other applications that are LDAP consumers, then I need to be able to apply those personalities and actually compose those personalities. So this has another side effect. As I take those policies and I'm beginning to apply them to microservices, I also need to decompose those policies into micro policies. So I have alignment in the size of my policy to what it's protecting. And by doing that, I get a policy now that is very behavior targeted, is very understandable from an audit perspective, and I can begin composing those policies onto my app. I have another advantage too. When the developer gets ready to launch an app, all they have to do is describe their app with the various labels that talk about the personalities that app is going to have. I don't have to go back and consult the compliance or security team because they've already upfront defined how the relationships between types of apps and the behaviors that they expect to occur, how they need to be arranged and the policies that need to be applied for those conversations to be compliant. And so as a developer, all I care about is labeling my app correctly. Additionally, in a orchestrated environment, I can scale that app or the different components of that app. And now, as I scale that app, I don't have to go and add additional rules into my firewall. As long as those labels are applied to the instances that get scaled, the new instances will inherit all of the policies that are identified and applied based on the labels that were given to the app's deployment. And so now I have a way to not only agilely move apps into my compute environment, but I can also scale them with the assurance that the right policies are going to be rendered on every component of that app at runtime. More and more, as microservices are adopted more and more, your dependencies between these components are going to begin to look something like this. And unfortunately, the traditional model of entrusting all of that information to a centralized group becomes impossible. It's impossible for any one person or any one group in the organization to understand the relationships between all of these microservices. And so we have to find some way that we can delegate those responsibilities so that we can ensure that global compliance and regulatory compliance actions are taken from a policy perspective and applied, but we can let platform administrators and developers target some of the more specific technology-based policies on their applications because they understand their applications better at that level. Another way to look at that is the compliance and the security teams are focused more on the relationships between applications, the types of communications that are going to occur, where the platform and the developers, they care more about the technical implementation of that. What ports am I using? What protocols am I using? And when I begin to delegate that policy in that way, I can now manage a much larger relationship of microservice dependencies. And not only the static picture of that, but it's also constantly changing as I'm adding new features and evolving that microservice ecosystem within my organization. One way to think about this is setting up policies in tiers. The InfoSec team would want to make sure that any policies that they're creating would take precedence over any policies that got delegated to other groups. Things like putting deny policies in for specific embargoed countries and known bad actors on the internet. Things about relationships for PCI workloads. All of those things are very global in nature, and those can be specified at a very high precedence in the policy evaluation order. But then when I get down to how I'm dividing out things like production workloads from testing workloads and development workloads, and then how I'm getting into very specific application policies, what ports are being used for communication, that kind of thing, I can start to delegate those to lower tiers, as you see here. So coming back to the comparison that we looked at earlier, we said, we're traditional, a traditional model, north-south traffic was the predominant form of communication. In the new model, east-west traffic is the predominant form. We've moved from centralized firewalls to host-based firewalls. We no longer are using the IP address for identity, right? IP addresses are ephemeral now, so we have to use things like labels to render policies just in time because IP addresses are constantly changing. In the old model, we had very coarse policy zones. But what we really want is zero trust and being able to take the policy or the firewall barrier and snug it up and around a specific microservice. So each microservice has its own unique firewall. And then finally, the rule changes are hard in the traditional model, right? Because of all the manual steps and the reconciliation that has to take place in the handoff from one person to another. In the new model, if we want to remain agile, we have to think now of policy as code that can be composed with metadata and can support things like canary deployments and be delegated. We want to move to a model where it doesn't take days to weeks to complete something, but where it can take minutes to complete something. So here at Tigera, we offer a solution called CNX that does a lot of the things that I've discussed today. We do the microservice and application segmentation using a zero trust approach. We are able to map applications and policies at runtime using labels. We also understand policy precedents, and we can use role-based access control and multi-tenancy support to determine which policies take precedence over other policies. This allows that delegation model so that no one central group within an organization has to understand how all the inner workings of every single application. Additionally, we support all major clouds and on-premise Kubernetes providers, and can also support other types of orchestrators and even bare metal and virtual machines. And then finally, our policies again are host-based, right? They're not a firewall that's going to induce a topology within your organization that's not effective, and it doesn't give you the level of granularity you need. We make sure that every single virtualized workload is protected at the source and can provide that sort of granular enterprise level security that's needed in a cloud native world. So that brings me to the end of the presentation, and we're going to move into a question and answer session. I'm glad that you joined, and I'd love to hear your feedback and any challenges that you're dealing with within your enterprise. So Andy, I'm going to pass it back to you.
Thanks a lot, Cody. So there's been quite a bit of chat that's been going on in the chat box. If there are any questions, if you could please log them in the Q&A section. I'll give about 30 seconds or so for you guys to add your questions, and then I'll start firing them off at Cody. Okay, so questions are starting to come in. So the first question, Cody, is how do you differentiate between Istio policies versus network policies?
That's a good question, Andy. We really didn't get into Istio today. I believe we have another website that's going to address that a little more specifically.
All right. Is there a management UI for network policies?
Sorry about that. I lost my audio for 1 second, Andy. I wanted to go back and address that question. So before I get into the management piece, in terms of Istio policy, we're going to have another webinar on that. And what I can say about that is that there are different layers within the network that policy is implemented. There is a layer 3 and 4, which is typically where IP runs. And that's where your network policies are going to be implemented. And that's primarily what I was talking about today. But in a zero trust environment, you really want to cover all those layers, right? You want to have not only layers 3 and 4, but you want to go all the way up to layers 5 through 7, which is more of your application layers. And we use Istio as a higher level way to look at layer 7 traffic to implement policies there. And we actually cover both of those policy vectors. So again, I'll cover that more in more detail in a later webinar. And so let's move to the next question.
Okay. Can the network logs be sent to Splunk?
They certainly can. We actually have scrape endpoints on every single, component within our control plane. And so what those scrape endpoints allow us to do is we actually use something called Prometheus to gather metrics data, and we also use standard logging. So you can use something like, in some cases people use Splunk, other cases people use more of a elastic fluent Kibana mechanism to pull that data out, but you get both real-time metrics and you get all the logs that you would need for auditing. And so we can definitely direct those logs and those metrics to whatever collection system that you use within your organization.
Got it. And I think, did we get to the question of management UI for network policies?
I'm sorry, yes, the management UI for network policy. We certainly have a management UI. And if you're interested in seeing that, I encourage you to contact us at our website, tigera.io, and we can look at setting up a demonstration for you.
Got it. Okay, I've got a few more questions here. So you showed a slide with many cloud vendors. Does your product work with all the ones shown?
It does. A matter of fact, we are, in many cases, the recommended policy engine in those public cloud providers. So currently, for example, if you launch a Kubernetes cluster in GKE, the policy, if you turn on network policy and container security policy, it's going to be using Project Calico and soon to be CNX under the hood. So we're supporting Google, we're supporting AWS, we're supporting Azure. We've been in IBM for a very long time. And if the public cloud is not where you're wanting to do this, but doing it on premise, we also have partnerships with Docker and with Red Hat, to name a few. And they can, out of the box, install our policy engines and get you up and working in no time.
Great, thank you. There's another question here that I can help answer. When will the Calico policies be integrated with Azure AKS? And so that's going to be reliant upon their launch date of the service, which, you know, since that's not our product to launch, that's really up to Azure at this point. One last question here. How does CNX compare to Istio?
Great question. So the way that we, the CNX works, first off, Tigera is the company behind Project Calico. And so Project Calico is the open source project that launched everything that we're looking at today. And so it provided all of the reachability and network security at those lower layers 3 and 4 that I talked about. We also, last year, joined the Istio project and are actually co-chair, for example, the security working group there, and work very closely on that project. And when you take Istio and Calico, we combine those together using our commercial product called CNX so that we get full coverage across the stack. So what CNX is doing underneath the hood is it's actually using some of the key primitives from Project Calico to protect the network, and then we integrate with Istio to protect the higher layers. And what that gives you as a customer is I can write one policy that covers the entire network stack without having to worry about all the individual configurations of both Istio and Calico. I just launch CNX, write my one policy, and it gets deployed in both places.
All right. So there's many more questions rolling in, and I think we have a little bit of time. Is this okay, Cody?
This is great.
Okay. What is the difference between CNX and Calico?
Great question. So again, Calico is the open source project. There's a very vibrant community. I welcome you to go download it and install it. It's free open source software that we've contributed. And it provides some of the core network protections and network policy protections that you would need for securing containers within something like Kubernetes. However, when you start getting into more advanced scenarios, for example, being able to tier those policies or being able to audit and log those policies, or when you start caring about role-based access control and how it integrates with users and namespaces and multi-tenancy, those types of things, that's where we offer our commercial product called CNX that takes the core components of Calico and extends them for the enterprise. This is where we introduce things like zero trust security, the multi-cloud, multi-orchestrator approach. Here we have all the organizational alignment to your security needs. And again, we, just like Project Calico, made things simpler by keeping everything as a flat, layer 3 network. we continue to build on that by providing things like the user interface and other mechanisms for users to be able to interact with these policies to make it accessible to the entire enterprise.
Okay. So I've got two more questions here, and I think we can probably close up. So are any firms using CNX for production?
We have 2 projects in process right now, so yes. And then we've had several other firms that have been testing our project for a very long time. So absolutely it's being used, and these firms that we are using the current project, again, CNX has only been released for now a couple of months, and so these firms have been with us through both Project Calico and some earlier products, commercial products that we had as well. And so CNX is continuing to evolve. The good news about this is we've had the opportunity over the last several months to take a lot of input from users of our system, and as we've just dropped CNX version 2.1, it's including a lot more of these advanced features that the organizations need, like for federation of policy. And so I would encourage you, if you want to know more about, the types of, organizations we're working with. Most of the organizations we're working with are we've got Fortune 10 organizations across multiple verticals. These are not small compute environments. And so, give us a ring, and we'd love to, understand what your scenario is, schedule a discovery and demo with you, and see if we can help you.
Okay, thanks. We've got time for one more, and then there's still some questions coming in. What we'll do is, we'll get back via text on these. So the last question here is, how does Terraform work with CNX?
So that's an interesting question. I'll preface it with this. We are extremely flexible in the target environment that we can install into. So as I mentioned, we support multiple clouds. We support multiple orchestrators, things like OpenStack and Mesos and Kubernetes, to name a few. We support bare metal machines if you just want to protect your hosts. And so with all of these various scenarios and all the different clouds, and in some cases, even Kubernetes as a service offerings, as well as specific distributions on premise, every organization provisions their actual physical infrastructure in a little bit different way. Where we target, our installation typically targets after a cluster has been brought up, after the physical machines or the virtual machines have been provisioned, the underlying orchestrator has been installed, then we are installed into that cluster. So Terraform is usually used to provision physical and virtual machines. And so it typically happens a priori before our installer runs. And so some organizations that are doing like a Kubernetes kind of build your own, the hard way, the Kelsey Hightower kind of approach, build Kubernetes the hardware or a vanilla distribution, they may incorporate pieces of our installation into their Terraform script. And if that's the direction that you want to go, let us know, and we definitely have the expertise in-house that can help you set that up.
All right. Well, thanks, Cody. That's all the time that we have for the Q&A today. Any other questions? Definitely reach out through the website. We have a contact us button, and we'd be happy to answer any of these questions offline. A copy of this webinar is going to be, this webinar has been recorded. A copy will be sent out to everyone who's attended, and will shortly thereafter be available for on-demand viewing on the website. Thanks so much, everyone, for joining. Have a wonderful day.
Thank you very much.